friends, welcome to the channel of Digital to Real. Today I am going to discuss about the mailboxes in System Verilog. So, what is mailbox? So, System Verilog has a predefined object-oriented mailbox class. Already in my previous video, I have discussed about the OOPS concept, object-oriented programming concept, which is available in System Verilog. OOPS concept is nothing but it deals with the objects and classes. So here in System Verilog also we have a already defined class, that is mailbox, in the standard library. So mailbox is a communication mechanism where messages can be placed in mailbox by one process and the messages can be retrieved by another process. What we do in communication? When we want to deliver some letter to somebody else, some information we want to send to somebody else, so we will drop a letter into a mailbox and that letter would be delivered by the postman or the delivery boy to the recipient. So the information or the message is taken from one place and put into another place. Or I can say that message is placed in the mailbox by one process and message is retrieved by another process. So similarly, what I said, mailbox is very much similar to the concept of delivering a letter via the delivery boy or the postman. Now, if the post has not been delivered, what a process can do? A process can choose to wait for the post delivery, or it can come back later and check again. So either it can wait and see whether the message it is receiving or not. Or what it can do, it can suspend the work at present, it can go back and come back again and see whether the message it has got or not. So this is how the mailbox works. Mailbox are of two types. One is bounded mailbox, another one is the unbounded mailbox. Bounded mailbox is full when it contains the maximum number of messages. It is like a mailbox is nothing but just like a FIFO. There is a fixed depth of the FIFO. Similarly, there is a fixed size of the mailbox. So we are putting messages into the mailbox. They are all going and stacking inside the FIFO. And on the other end, it would be retrieved. Other process would be retrieving the messages from the FIFO also. So what the bounded mailbox does? When the bounded mailbox is full, that means that it has the maximum number of messages. If a process tries to place another message into a full mailbox, what it has to do? The process has to wait until there is a room, until there is a space for the mailbox queue. What is unbounded mailbox? So unbounded mailbox never suspend the send operation. In the bounded mailbox, there is a dependency, means there is a dependency of the size of the mailbox. If the messages are full into the mailbox, you cannot place message into the mailbox. You have to wait and you have to see whether when the mailbox is going to be not empty but space is going to be get available for the message to be put. But in unbounded mailbox, this waiting thing is not there. And we never suspend the send operations. As I said, in System Verilog, mailbox is a built-in object class. Okay. Now, how to construct the mailbox? So, we have a function called new. New function is used in order to construct a new mailbox. So, we write it like this. Mailbox, this is the keyword. FIFO_1 is equal to new semicolon. So FIFO_1 is the mailbox which is constructed using the new function. Construct mailbox called FIFO_1. So the mailbox size can be bounded or unbounded, as we said. So a bounded mailbox, as I said, has a fixed number of size. So how to set the size of the mailbox? That is also done through the new function. Same new function by passing an argument into it. Just see. Mailbox FIFO underscore 2 is equal to new inside bracket 8 semicolon. So this is how you are constructing a bounded mailbox. So mailbox can be typeless or typed. A typeless mailbox can transfer any data type. So mailbox can be typed, means it can hold a particular type of data type only, or it can, there is no limitation of the mailbox, means whether it can hold only a certain type of data type only, or it can hold different type of combination. If it is holding only a particular specific type of data, then it has to provide that the keyword of type, means whether it is integer type of mailbox, whether it is a floating type of mailbox, what it is actually, that we have to provide. The keyword has to be provided. A typeless mailbox can transfer any data type, that is what I said. It can hold any type of data. But the user must ensure that the data is retrieved as the same data type in which it was stored. So this mailbox is nothing but like a FIFO. So when you are putting a data into a storage location of the FIFO, you might be knowing what is the type of the data. While retrieving the data from the other end, from the other process, what the FIFO works? FIFO works like first in, last out. So when the other end, the user is retrieving the data from the FIFO, from the mailbox, it has to make sure the data type is same. Mismatch should not happen. Then it will give the runtime error. So runtime errors come if we try to retrieve wrong type of data. So typed mailbox, I will show you with an example how the typed mailbox look like. A typed mailbox can only transfer data of a specific type. Sending or retrieving the wrong type is a compile time error. So here in typed mailbox, if you send some other data type and retrieve some other data type, then you will get compile time error. While in the typeless type of mailbox, you used to get the run type of error. The mailbox type is defined using a parameter redefinition. See how the parameter is passed. In the Verilog also used to see how the parameter are used to be passed. Similarly, mailbox, hash, inside bracket, the data type. Here it is integer. FIFO underscore 3 is equal to new 8 semicolon. So this is how you are constructing a mailbox. Size of the mailbox is 8. So it is a bounded mailbox. And the data which will be held inside this FIFO underscore 3 mailbox is of type integer, int. And the System Verilog mailboxes are having many built-in methods. So we will discuss about them. First method is put inside bracket the message or the data type. Put. It places a message into a mailbox. Now if the mailbox is full, the process is suspended or it is blocked until there is a room in the mailbox to place the message. We have the function, we have this method get variable or get message. So it retrieves the message from a mailbox. If the mailbox is empty, here also the process is suspended or blocked until a message is placed in the mailbox. So these are block type of method available with mailbox. Let's see with an example. Example, mailbox hash integer FIFO is equal to 8 new 8. So this is how I am constructing a mailbox. Name of the mailbox is FIFO and maximum data is it can hold is 8. Next is int data underscore in semicolon. Okay, then always at the rate of passage of the write clock. Passage of the write clock, what I am doing, if the data ready signal is available, if the data ready signal is available, So I'm putting data into FIFO mailbox. FIFO dot put inside bracket data underscore in semicolon, and here is the end. For this begin, this is the end. Now you see the retrieving process. So int data out semicolon, always at the rate of pause edge of the read clock. When the read clock is there and it is of pause edge, means 0 to 1 is there. Inside the begin and statement, FIFO dot get data out semicolon. So non-blocking mailbox method. Earlier we studied about the blocking method, now the unblocking method. Mailbox can be used without blocking the process execution. Now here is the first one. Status is equal to try put. Inside the bracket it is message. It is try underscore put or try put. You have to make sure which is the particular method of the mailbox. Mostly it is try underscore put. So try underscore put message. So this is similar to put method, except that the process does not suspend if the mailbox is full. If the mailbox is full, the process does not suspend. The status, it returns value 0, 1, whether this try put is successful or not. So if the status value is 0, means that try put returns 0. That means that if the mailbox is full, the message is not delivered. And if that status comes as 1, that means is mailbox is not full, the message is delivered. There is another method, that is try get. So status is equal to try get. Inside the bracket it is message or variable. It is similar to get, except that the process will not suspend if the mailbox is empty. This is unblocked type of method. So this particular method try get, it will return 0 if the mailbox is empty, and it is return 1 if the mailbox is not empty, and the message type matches the argument type, means whatever the message I want to retrieve or whatever the data type I want to retrieve from the mailbox, it should match the type of data that has been put. Now returns -1. Here this try get can return 3 type of values, 0, 1 and -1. It will return -1 if not empty. If the FIFO is not empty, but message type does not match the argument type, means the type of data I want to retrieve from the FIFO does not match with the data available inside the FIFO. Let us see the System Verilog mailbox example. So I have a process 1, that is the generator class. What the generator class will do? It will generate, that is create and randomize the packet, and it will put it in the mailbox. The name of the mailbox is MB box. There is another process, that is a driver class. It will retrieve the generated packet from the mailbox and display the fields. So let's see the packet class. Class packet semicolon rand bit 7 down to 0 address semicolon rand bit 7 down to 0 data semicolon. Displaying randomized values. Now I am displaying the randomized values. Means after the randomize function will be called for the packet. This function void post randomize. The post randomize function is called after the randomize function. And this post randomize function, what it does? It will display the packet contents. Means packet address, it will display packet data, it will display. You see this $display statement. First $display statement says that the message is from the packet class and the packet is generated. Second $display statement, what it says? The message is from the packet class and address is equal to %0d, comma data is equal to %0d. Mean address and data. Now it is, so that thing is done. Means inside the packet we have randomized the address and data, and then we have put the function, definition of the function post randomize. Now we will see the generator class. Generator class generate the transaction packet and send the driver. Okay, so class generator semicolon packet. So this is the packet handle, packet pkt semicolon. So pkt is the packet handle. Mailbox m underscore box semicolon. So mbox is also the mailbox handle. I have to construct this. I have to build this both pkt and mbox using the new function. So constructor does the job of, the new is called the constructor. It does the job of building the packet and mailbox. So constructor, it getting the mailbox handle. Function new mailbox, inside the parenthesis mailbox m underscore box semicolon. So here we have got the reference of the mailbox mbox, and we are newing it, we are building it. After we getting the mailbox handle, we are newing it. So this dot m underscore box is equal to m underscore box semicolon, and this is end function. Now here is the task run. In the generator, task run is there. So repeat to begin. So means repeat to means whatever is inside the begin and statement, those set of statement will be repeated 2 times. So packet pkt is equal to new semicolon and pkt dots randomize semicolon. So packet is generated, packet is randomized. Once the packet is randomized, post randomized function will be called, content will be displaced. Then what I am doing is that mbox dot put packet semicolon. So already we have built the mbox. Now I am putting the packet into it, putting the packet into the mailbox, and we have this display statement which shows that the message is from the generator packet put into the mailbox. So once the packet is put into the mailbox, we will display this message #5 semicolon. We will wait for 5 time unit, then end. For the begin, we have the, for this begin, after the repeat, we have the end. Then we have end task for the task run, and then I have the end class for the end generator, class generator. Now the driver class. So driver gets the packet from the generator and displays the packet items. So class driver semicolon. Inside the class driver, I have the packet pkt semicolon, mailbox m underscore box semicolon, constructor getting the mailbox handle. So for that purpose, I have the function new inside the parenthesis. I have the reference to the mbox, mailbox mbox semicolon. This dot m underscore box is equal to m underscore box semicolon end function. New function in order to construct the mbox, mailbox. Then similarly, like the generator, I have the generator block, I have a generator class, I have a task run here also. So task run, repeat to, very much similar to the generator class, repeat to begin mbox dot get packet semicolon. There it was mbox dot put, here mbox dot get packet semicolon. Now here is the comment, getting packet from mailbox. So I have to display the content of the driver class. So first display driver packet received. Packet received, this message should come from the driver class only. So driver, it has been mentioned. Then $display driver address equal to %0d, data %0d, comma packet address and packet dot address and packet dot data. So here I am getting the address and data for the respective packet. Okay, after getting the packet from the mailbox. So inside the mailbox, using put, we have sent the data from the generator, and the driver class, what it did, it retrieved the data, and here we are displaying the content of the packet dot address, packet dot data. So here is the hierarchical path has been provided, pkt dot address, pkt dot data. So here is the end for the repeat statement, repeat begin for the begin end task for the task run, then end class for the class driver. At last we have come to the test bench top. How the test bench top will look, module mailbox underscore exe semicolon. This is the module definition I am providing. Module name is mailbox underscore exe. Inside the module I have put the instances of generator, driver and mailbox. Generator GEN semicolon, driver DRI semicolon, mailbox M underscore box semicolon. So this is how we are declaring the mailbox, generator, driver. Now initial begin end block we will see. Inside the initial begin end block we will create the mailbox. While creating the mailbox we will pass the same handle to the, after creating the mailbox, same handle will be passed to the generator and the driver class. Okay. So as the mailbox does the inter-process communication, so the same handle will be used by generator and it will be used by the driver. So here I am doing M underscore box is equal to new semicolon. So this is what it's creating the mailbox. After creating the mailbox, create the generator. Gen equal to new. Inside the new M underscore box semicolon. So when I am calling the generator new function, so inside the new function I am passing the handle of the mailbox, M underscore box semicolon. After doing this, I am creating the driver now. DRI drive is equal to new, inside the parenthesis M underscore box semicolon. Here also, in this new function, no, in the gen case, what we were doing, we were passing the handle of mailbox. Same mailbox handle has been passed to the driver also. While constructing the driver, same handle will be used. Because we saw in the generator block, there was a new function. In the driver block also, that is the driver and generator class, they were the new functions. You see, inside the driver there was a new function, function new, inside the bracket mailbox M underscore box semicolon, and this dot M box is equal to M box semicolon end function. This how it was there. Now M box is created, gen is created, driver is created. Now we will show the display. So $display, inside the double quotes we have all dash dash dash. Now this fork join, this particular block is called. Inside the fork join, gen.run and drive.run. Both the processes will be run simultaneously. Process 1 and process 2. Both will be run simultaneously. That is parallelly. So whatever we write inside the fork join command, no, fork join set of statement, that is run parallelly. And then we have the $display, that also double quotes. Inside the double quotes all dash dash dash. Displays are put in order to have a proper log file, so that we can look into the log file and see what is actually going through the whole system, this class based system. Here is the end and here is the end module. So hope this mailbox is clear to you. If you like the video, please share with your friends. Please subscribe the channel and have a very nice day. Bye bye.